Hello everybody, I'm Nikhil from App Store Engineering. Today we meet Ad Attribution Kit. Privacy is a big part of everything we do at Apple. Privacy-preserving ad attribution enables advertising attribution while preserving user privacy. Privacy-preserving ad attribution is built on top of crowd anonymity. At a high level, crowd anonymity will send less data back to ad networks and advertisers when there are fewer conversions. As the crowd size scales up, more data is sent back. Once the crowd size passes the highest level, the maximum amount of data is returned to ad networks and advertisers. SKAdNetwork was Apple's first privacy-preserving ad attribution framework powered by crowd anonymity. Today, I'm happy to introduce Ad Attribution Kit, our new ad attribution framework for iOS and iPadOS built on top of SKAdNetwork fundamentals. Let's begin by talking about ad attribution at a high level. Ad networks generate, sign, and serve ads to publisher apps. Publisher apps display the ad to the person using them. They install the advertised app, and as they engage with it over time and after the measurement period has passed, a postback containing conversion information is sent to the ad network. With that flow in mind, here are the topics I will be covering today. We will start with a discussion on fetching ads and the new ad impression format in Ad Attribution Kit. Then we will look at displaying ads. We'll follow this with a discussion about postbacks. Then we'll go into re-engagement and briefly cover testing Ad Attribution Kit. Let's talk about fetching ads. Ads are the input to the attribution flow. The publisher app will fetch the ad data from the ad network. This ad data is in compact JWS format. I will now go over the fields. Here is an ad impression in JSON form. I will cover a few important fields. The advertised item identifier is the app ID of the app being advertised. The publisher item identifier is the app ID of the app showing the ad. The source identifier is a 4-digit integer used to represent campaign-related information for the ad. This field retains the same behavior from SKAdNetwork 4.0. The fields in the JSON are described in the Ad Attribution Kit documentation linked to the session. With that structure in mind, let's move on to ad impressions. App impression instances represent ad impressions. These instances are initialized with the ad's compact JWS representation, which we covered in the previous section. I will now show you how to create an app impression from the compact JWS. First, I fetch the ad's compact JWS representation. Note that the fetch ad impression JWS method is not shown implemented, since this is entirely up to how I integrate with my ad provider or ad network. I then pass this JWS string to the initializer for app impression. I will be using this app impression instance in the next section to discuss displaying ads. Ad Attribution Kit supports 3 different methods of displaying ads. Let's take a look at the ads I want to display for my advertised app. The first ad is a custom creative that is clickable. Tapping a custom click ad will navigate the user to a marketplace where they can install the advertised app. Here is a view-through ad in a different screen. An example of this type of ad content can be a video ad. Another ad type simply recommends the advertised app. For this, I can use SKOverlay, which shows up as a banner within the context of my app. Or I can use SKStoreProductViewController, which is more of a full-screen presentation model, still within the context of the app. Both SKOverlay and SKStoreProductViewController share the iOS design language and are extremely easy to adopt and plug in to my app. Here is how to implement a custom click ad. First, I create the custom ad view. Then, I create an instance of UI Event Attribution View and add it as a subview of my ad view. Note, the UI Event Attribution View has to be on top of any view that receives user interactions. With the ad view set up, let's handle taps on it. When the user taps on the ad view, I grab my instance of app impression and call the handle tap method on it. Note that handle tap has to be called within 15 minutes of when the app impression instance is initialized. Past 15 minutes, create a new app impression instance. When the click happens and you call the handle tap method, Ad Attribution Kit navigates the user to a marketplace from where the advertised app can be installed. For view-through ads, I previously mentioned the usage of a video ad. However, view-through ads can cover any custom ad presentation. I'll use a simple timeline to help visualize the events and API calls involved. When the ad presentation starts, I call the Begin View API on my app impression instance. And when the ad presentation finishes, I call the End View API on my app impression instance. In my specific case of the video view-through ad, when the video starts playing, I call Begin View on my app impression instance. And when the video finishes, I call End View on my app impression instance. A few things to note about view-through ads. Your custom ad content needs to be displayed for a minimum of 2 seconds, meaning the time between calling Begin View and End View should be at least 2 seconds. This matches the industry standard for this type of ad content. Begin View and End View need to be called on the same instance of app impression. And the same ad network cannot have multiple open view-through ad presentations for the same advertised app at the same time. Every call to begin must be balanced by a call to end. Moving on to SK Overlay. Implementing SK Overlay follows the same pattern in Ad Attribution Kit as it did in SK Ad Network. We use instances of app configuration to set the SK Overlay up. You will set your instance of app impression to the new app impression property on app configuration. Finally, SK Store Product View Controller. The setup for SK Store Product View Controller is similar to how it was set up in SK Ad Network. The load product method is called to prepare the product page UI for display. The main difference is the impression parameter on the load product method, to which you will pass your app impression instance. And now, postbacks. Postbacks are the outputs of the attribution system. They are the conversion signals sent to the ad network. They are also optionally sent to the developer of the advertised app. Ad Attribution Kit sends postbacks as a combination of a signed compact JWS and a few unsigned fields. Here is the signed portion. Let's focus on a few important fields. The conversion type field carries information about the type of conversion that created this postback. The values for this field can be download, re-download, or re-engagement. The marketplace identifier field carries the identifier of the marketplace where the conversion occurred. In our examples, because the download is taking place on the Apple App Store, this field has the value com.apple.appstore. The publisher item identifier is the identifier of the app that showed the original ad. For low levels of crowd anonymity, this will not be included in the postback. The source identifier has a minimum of 2 digits and a maximum of 4. Crowd anonymity determines how many digits are included in the postback. Let's now take a look at the rest of the postback request body. The JWS string key holds the JWS compact representation of the JSON we just covered. Note that I'm showing a placeholder here and not the actual string for the sake of brevity. The add interaction type key holds information about how the user interacted with the ad. The possible values for this are click and view. I will go into detail about this key in a subsequent section. The conversion value key holds the value of the conversion as determined by the advertised app making API calls to Ad Attribution Kit. Note that conversion value is also a crowd anonymity controlled field, and as such, it is not guaranteed to be present in the postback. If crowd anonymity determines the data allowance to not be high, instead of the conversion value, you might receive the coarse conversion value. Or you might receive no conversion value at all. Going back to the full postback request body, I want to dive deeper on two topics: the conversion value and the ad interaction type. First, conversion values. Conversion values can be used to measure advertising effectiveness. In other words, how valuable was this ad campaign to my advertising needs? The conversion value can also be used to derive information about the return on ad spend, or ROAS. This is quite an important heuristic for determining future ad spend and related optimization. Note that conversion values can be fine or coarse. This is determined by crowd anonymity. I will go over 3 scenarios where I want to measure user engagement and update the conversion value via Ad Attribution Kit. Let's look at an account creation scenario first. Assume that we are inside the method handling account creation in the app. I will first create a postback update struct, and then I call the update conversion value method on the postback type to execute the update. Let's take a closer look at the postback update struct's properties. The first argument is the fine conversion value. This is a positive integer between 0 and 63, both values included. Note that the values for the fine conversion value need to make semantic sense for my advertising campaign and how its effectiveness is being measured. Typically, the schema for conversion values would be determined after discussion and planning between me as the advertised app developer, my chosen ad network, and any MMPs I might choose to work with. The second argument is for locking postbacks. The lock is a way for me to tell Ad Attribution Kit that I am finished measuring and recording conversion values for that particular conversion window. This allows Ad Attribution Kit to freeze that postback and immediately schedule it for transmission. Another way to think about this is that a very high-value event happened that I want to know about as soon as possible. The time urgency of this event beats out measuring anything else in that conversion window. Hence, I call lock, and Ad Attribution Kit knows to freeze and schedule this postback. Account creation does not have enough value for me to lock the postback. Therefore, I use false for the lock argument. The final argument is the coarse conversion value, which can be one of 3 string values: low, medium, or high. As mentioned before, the coarse value is sent in the postback when crowd anonymity determines that the fine value cannot be sent. With the account created, the user watches their first video. I consider this a higher value event, and so I update the fine conversion value to 38. The value of the user watching a video is not high enough for me to lock the postback, and so that argument is false. And if my fine value cannot make it through due to crowd anonymity, I set my coarse conversion value to be medium as a fallback measurement. Finally, the user uploads a video. I consider this a very high value engagement, and so I update my fine value to be 42. Video creation is a very high value event, and I want to receive my postback as soon as possible. Therefore, I lock the postback via the lock postback argument in the API. Note that locking the postback does not lead to its instant transmission. This delayed transmission behavior is to further protect user privacy. Again, as a fallback, I set my coarse conversion value to be high. You can use the postback update structure to set your conversion value for different scenarios in your app. The last thing to cover for postbacks is the ad interaction type. Ad Attribution Kit distinguishes between the user tapping an ad and simply viewing it. This information is crucial for the selection of the ad that drove the conversion. The ad interaction type in the postback will have the value click or view depending on the user's interaction with the ad. Let's review the value of this field for different presentation methods. For a custom click ad, viewing it does not create an impression. Tapping it results in an ad interaction type of click. For a view-through ad, viewing it results in an ad interaction type of view. Tapping it does not create an impression. For SK Overlay, presenting it results in an ad interaction type of view. Tapping it results in click. Similarly, for SK Store Product View Controller, presenting it leads to an ad interaction type view. Tapping it leads to click. Conversion values and ad interaction type provide details about the user engagement with your app and the ad that drove the install. And now for something even newer, re-engagement. The main purpose of ad attribution is to attribute a conversion event to an impression event. In our examples thus far, I used installation as the conversion event. The initial goal for many ad campaigns is to drive installations for the app. This makes sense since installation is the first step in the user's journey with the app. Now, let's talk about a new type of conversion event, re-engagement. For re-engagement ad campaigns, the goal is to bring users back to the advertised app. Consider the case where the person who installed the advertised app stopped using it. The advertised app wants to recover this user. And so they run an ad showing a limited time offer. When the user taps on the ad, Ad Attribution Kit opens the advertised app to the screen with the offer, and the re-engagement begins. Let's take a look at a re-engagement ad impression. For opting in to re-engagement, I will add one more parameter to the payload. Eligible for re-engagement. This tells Ad Attribution Kit that the ad impression is to be considered for re-engagement conversions. An ad impression configured with the eligible for re-engagement property is considered for re-engagement or install, depending on whether the advertised app is installed or not. For a normal ad impression without re-engagement opt-in, it would only be considered for installs. Here is how to initiate a re-engagement in code. I create the app impression instance with the JWS string. Note that this is the JWS impression that has opted in for re-engagement. Then, in the tap handler for my ad view, first I get the universal link that I want the user to be navigated to within the advertised app. Then, I call the handleTap method on the app impression instance, passing in the re-engagement URL. This call tells Ad Attribution Kit to open the advertised app. When the advertised app is opened, the re-engagement URL is passed to it. Note the query parameter appended to the re-engagement URL. Ad Attribution Kit appends this parameter to the URL during a re-engagement. Advertised apps can check for this parameter to tell if an open was caused by an Ad Attribution Kit re-engagement. SK Overlay and SK Store Product View Controller are also compatible with re-engagement. The setup for both is very similar to an install. To open a universal link in the advertised app, you can use the Ad Attribution Re-engagement URL property on the SK Overlay. And for SK Store Product View Controller, you can use the re-engagement URL parameter on the load product method. Let's talk about the postbacks sent for re-engagement conversions. The conversion type key in the postback will have the value of re-engagement. Re-engagement conversions can only have the click ad interaction type. view-through re-engagement is not supported by Add Attribution Kit. The first call to update the conversion value must be made within 48 hours of the conversion. Re-engagement postbacks can be selectively updated separate from installation postbacks. I will show you how. Let's bring back the postback update struct we saw earlier. Use the conversion types parameter to control which postbacks get updated. For updating only the re-engagement postbacks, I use the re-engagement value for conversion types. For updating only the install postbacks, I use the install value for conversion types. For updating all postbacks, I use both install and re-engagement for conversion types. Add Attribution Kit also updates all postbacks if the conversion types parameter is nil. That covers re-engagement, which in addition to install presents a complete picture of how people are engaging with apps. Testing Add Attribution Kit can be difficult due to the asynchronous design by virtue of necessity and purpose. This asynchronous nature is further compounded by time randomization performed in order to strengthen our privacy behavior. To improve the ease of testability, we have a new developer mode for Add Attribution Kit. Developer mode removes time randomization from the system to make it time deterministic. It shortens the conversion windows, so testing of conversion value updates can be done in all 3 windows in a test-friendly timeframe. Developer mode also speeds up postback transmission to help with testing. Let's look at how to turn on developer mode. In iOS settings, navigate to the developer menu and scroll down to the switch for Add Attribution Kit developer mode. When the switch is turned on, Add Attribution Kit begins to function in developer mode. The time durations in the system are shortened to enable faster testing. And that is all I have for you today on Add Attribution Kit, Apple's new privacy-preserving ad attribution framework for iOS and iPadOS. As an ad network, if you are already registered for use with SKAdNetwork, no further enrollment is needed. If not, you start by enrolling your ad network with Add Attribution Kit. After enrollment, the next steps would be to serve the new JWS format ads and display them using Add Attribution Kit. For advertised apps, adopt the new Add Attribution Kit APIs for updating conversion values. On the server side, receive the new JWS format postbacks and parse them for analysis. All the features discussed here today note that Add Attribution Kit is fully interoperable with SKAdNetwork. And for more information about SKAdNetwork, check out the WWDC 22 session, What's New with SKAdNetwork. And finally, our Add Attribution Kit documentation is a fantastic resource as you get started with your Add Attribution Kit integration. Thank you so much for joining me today.